first of all, let me just introduce, this is Mr. Lawrence. He is a physics teacher here at Central Catholic. How long have you been at the school?
This is my 10th year here.
Fantastic. So, figured you might not, you have to wait a few years before you get him in the classroom, but here's a little preview, and I'm glad that you can share his scientific knowledge as we dive into the creation of the world.
Yeah, so specifically, I want to address the question that sometimes goes like this. That's like, so the Big Bang Theory can explain some pieces about creation, so doesn't that mean we don't need a creator? Which is just false. And I think if I explain to you a couple pieces about the Big Bang Theory from my point of view as a science teacher, it can help you see how understanding the science better makes it easier to believe in God. It makes it more believable. So we're going to take a little, 5 minutes is my guess. That's going to go like dominoes, and then sirens from fire trucks, and then the light from the stars. And I hope it ends with the Big Bang Theory says the belief in God is reasonable. So I brought a couple of props. I hope your childhood was good and included playing with these little rectangular dominoes. I hope so. You would have, set them up and made brilliant designs and knocked them over, and probably some of you were quite good at this, can get them in great little shapes. Even my 5-year-old can get them to be in a row and all fall down in order. They don't just do that by themselves. And if you were better at it, you could make better and better designs. I think we already know that. That's the dominoes piece. We're going to leave that for a minute. I think you have experience with train whistles or fire truck sirens. Don't be alarmed. I'm going to sing stuff at you. Ready? The siren goes by and it makes a sound like woo. You experienced something like that before?
Yeah.
The sound changes when it goes by you. That's called the Doppler effect. I think everyone's experienced that before. Some loud sound that's moving changes pitch when it stops going towards you and starts going away from you. It's not going to work for the people online, I'm sure.
Here's a better marker.
You got a better mark? So, sound waves, like all waves, spread out in all directions. If the fire truck was standing still and making its sound, it would not sound different, even if you were running as fast as you could towards it or away from it. It has to be reasonably the same speed as the wave that's moving. But the sound wave should move out in all the directions like the ripples on a lake or a pond or something. But as soon as you move this fast, like that way, then the waves on this side are bunched up closer together, and the waves on this side are spread out farther. These seem to be moving faster than the waves behind it. So depending on how much you love music, that's what explains the higher pitch was going towards you. It's because the sound waves are moving faster. And the lower pitch was moving away from you because the sound wave is moving slower. That pitch is related to frequency when we talk about waves. Frequency is like how often the wave does its whole up and down. The little air particles are forwards and backwards, and that's why your ears work. Anyhow, Doppler effect. You have experience with it. That's where we leave the fire truck. And we start to talk about the light from the stars. Probably you know things about stars. They're, far, far away. They give off light. You see them at nighttime. You wouldn't be able to see them at daytime except the sun's too bright. Some of them are much closer to us than other ones. And there are lots more we can't see because our eyes aren't good enough. So we get these fancy telescopes to see them for us. Okay, you understand that already. I brought a snippet from a physics book because I couldn't take the whole wall. This is a picture of a little black band that has little colors in it. These are wavelengths of light given off from 3 different types of atoms. Basically, stars come in 4 or 5 different popular types. You maybe studied them in junior high. They have a lot of similarities. Our sun is a yellow main sequence star. That means it's doing like hydrogen and helium fusion. There are lots of stars like our sun out there. And they all give off this same color that's like, you can't really see it great from that far away, but they all give off these same certain frequencies, wavelengths of light. Except, some of them that are far away from us give off slightly different, those exact same lines, because the Doppler effect is true for light waves as well. What that tells scientists is that some stars are moving towards us and some stars are moving away from us when we look at them with our telescopes. So you would expect like it to be about 50-50. Many of the objects should be moving towards us, many of them should be moving away from us. So some of them should have that frequency higher, like the pitch before the train passes you, and some of them should have that pitch lower, like the train after it passes you. Except that's not how it is. When we look at all the stars, many more of them are shifted like they're moving away from us. That's called redshift. I don't know if Mr. Tabor's made you do it yet, but you will probably eventually memorize the light spectrum, right? There's radio waves and then microwaves and then infrared light. Those are three with smaller frequencies so that our eyes can't see them. And then it does the order of the rainbow. Red, orange, yellow, green, blue. Ask him if violet counts. It'll save you like 30 minutes of class someday. He wants to call it far blue. I forget the whole story. You won't forget the whole story after you ask him. Those are the ones we can see, and then it's ultraviolet, and then it's X-rays, and then it's gamma rays. Those are too big of a frequency for us to see. So we call the light blue shifted if the star's moving closer to us, like the higher pitch sound. And we call the light red shifted if it's moving away from us. And almost all the stars we can observe with telescopes are red shifted, moving away from us. Which leads scientists to say the universe is expanding. And if the universe is expanding, the next logical question is, well, where was it? Does that mean sometime, a long time ago, the universe was all in one space? And that's where the Big Bang Theory comes from. It comes from this idea that at one point in time, all the matter we know about was in one small space, and it was dense, and it was crazy hot, and it started. And the universe has been expanding ever since. Which I think is ridiculous to believe that that would happen by accident. Sort of like these dominoes aren't going to set themselves up and then fall over. They certainly aren't going to like build themselves into a robot that's going to walk around and invent things like an oven. So similarly, you can understand the Big Bang Theory is this cool idea of maybe how creation happened, probably how creation happened, but there's no way it happened randomly. Like some intelligent creator had to put it together. I think you'll find that behind a lot of the science beliefs, that people say, because of this, you don't have to believe in God. If you understand the science a little more, it's just more plausible that there must be a creator. That's this much I wanted to tell you. Is there something I missed that you want to know about? It's lovely to see you. Is there anything else you want me to talk about?
I think that's great because we're just getting started on creation. As I was telling them, it doesn't have to be a battle between science and religion. We're on the same team here.
That's right. Ooh,